Mm.
Yeah, good morning. Good morning.
Good morning, sir. Good morning, sir.
Good morning.
Good
Yeah,
morning, sir.
I'm back here with an IoT class. In a last class, we have completed Unit 3. That is, we have gone in depth of the different technological terms, that is, the device and gateways, and we have clearly gone with how a device will work and what is the work of a device and all. Then, in next stage, as a gateway, how gateway will be connected to the network and what is the work of a gateway. Some devices will be the combination of both the device and the gateways, how it will work. So that and all we have discussed. And later on, we have gone with another one important thing. What is the need of a network? So what is the role of network, especially in IoT projects, and how this network will play the role in both the M2M projects and an IoT projects. What is the importance of this, especially the networking when the ABC network is there. And we have seen within a different terms and technologies that how a different heterogeneous networks will be connected together, short range networks, long range networks, internet, public network, how it will be connected, and what is the role of that networks. And finally, we had discussed the wide area networks, when it will be used, especially in a large IoT projects, when you have to cover a large areas in a kilometer wise. If you want to cover like that, it is there. Then how the sub networks you are going to do, and that sub networks how you are going to connect with the main networks, internet. So WAN technology, how you are going to apply, especially in a wireless sensor networks for a large area. So that we had discussed in a wide area networks. And coming to the local area networks or capillary networks, very small networks will be there for a small area wise. You can say like this, 500 meters maximum, like that, and maximum 1,000 meters within that. So how you are going to connect to the internet, and how you can pass the data to the cloud with a device and all, and how these local area networks will help you in different strategies in this particular networks. So all the 27 projects what we are doing is the thing that are all the local area networks which we are going to use. So that we had discussed in the network concepts. And later on we had gone with a discussion of data management. So that is another one very important concept, how a data management will be done, especially collecting a data from a sensors. So how data generation and data aggregation, and then the data processing, and then the data validations, and then finally how data will be taken into the consideration. So that and all we had discussed in data management with an examples and all. Later on we have gone with the architecture, means M2M and IoT analytics, means how an analytics will be done based on data or information what you are having, how you are going to do different methodologies in that we have seen, and we have gone with that particular cases. In a separate, we have discussed the ever service architectures, means the cloud computing we had discussed. That is exas. That is a one very important question from that particular unit. Definite question it will be there always in an exam, which I have observed from last 4 years question papers. So XaaS, how a cloud computing and what are the different services it is going to give, and how a deployment process of that particular cloud will be done. So that things we have discussed in XaaS. Later on, we have gone with the knowledge framework management or a knowledge management, and we have seen how a knowledge representation of final information can be done, and all we have discussed in a last class. So this is the overall summary of an unit 3, which are the important concepts which I have told you. So in this particular terms, The important questions yesterday I have given you, so you submit it as an assignment, and it will become a practice for an exam also. Now stepping into the next unit, that is an unit 4. Now I'll share the PPT of that. Just a minute. Yeah, coming to next in the unit 4, IoT architecture state of the art. And now in this particular terms we are going to discuss especially on IoT architecture, that is worldwide standardizations, how you can use an IoT projects or an M2M projects, how these worldwide standardization of an architectures will be useful, and how we should, why we should follow that type of an architectures to get a similarity worldwide IoT projects, and then what are the uses of that and what are the applications of that, that we are going to discuss in this. The main goal of this lecture is the actually here we are in an investigation how the different technologies introduced in a previous unit. That means in a previous unit we have discussed from device to so many technologies, so fit together in overall architectures. This is very much important. In overall architecture, where to place which technology, and how this technology will become a standardization. So which technology, that technology, what standards it should follow in a worldwide. Why these things will always comes. For example, assume internet TCP/IP architecture. Why worldwide the TCP suite will be taken into the consideration for internet? There's the standards of laws, and all the countries are accepting that. That's why entire global we can connect wherever you want, and entire global become a one community based on a public internet. That means all the countries over the world will agree on that particular protocols, and they will make it as a standardized. Like that, in IoT project, some standardization must be there. That is what type of sensors data we should use, and what type of sensors, and what actually the sensors should do, and how the network should be connected to that, and how the network layer should help in transmitting especially the device data from one area to another device, or a human being, or any other customer. So these things, how these technologies should be framed in architecture. So with reference to the relevant system level standards in a worldwide, there are two standards, that is ETSI M2M and IoT. So these two standards will be used especially. Just a minute. Just you give me the 1 minute here. Yeah. Okay. Coming over here, these two architectures we'll discuss in this particular unit in detail. Now, what are the things which we are going to discuss? Is first is an introduction, and then is an architecture reference model, and then is an IoT reference architecture, or IoT reference model. So these things we are going to discuss. It's a small unit, both fourth and fifth are a small units, which it can be completed in a stipulated time or within a stipulated time, not an issues, not like the second and the third unit, right? So coming to the introduction part here, in a unit 3, we outlined the technology building blocks that form the basics of M2M and IoT solutions. Yes, so we have discussed all about an technology, and we are thorough with the technology. Now we know what is the device, and what is the gateways, and what is the network, and how data management will be done, what are the tools for that, and different analytics, how we are going to do everything, cloud computing, everything concepts, technological concepts we know now. The term architecture reference model, that is ARM, here afterwards I'll call it as a ARM. So ARM means architecture reference model, is borrowed from the IoT architecture, IoT-A. So European research project, because the objective of the next topics is quite similar to that of the IoT ARM. So here afterwards, we are going to discuss whenever I will tell IoT architecture or architecture reference model, ARM, if I speak, that ARM is observed from the European research projects that is taken, that is especially from IoT architecture. So ARM, that is given in 2013. A reference model is a model that describes the main conceptual entities and how they are related to each other. So especially here, what this model will have, what this reference model will have means it will have a conceptual entities, means the entities which are relevant to that particular project. So that are the conceptual entities and how these entities are interrelated with each things, or how the sensor is related with a device, and how device is related with a gateway, and how gateway is related with the internet network and a cloud. So how the different data will be processed in different stages. So these things, so how they are related to each other, that we are going to study. While the reference architecture aims at describing the main functional components of a system as well as how the system works. So what is the main agenda of this reference model is like this. We are going to think like this: what are the main functional components which are present in this particular project? That means I am doing my project to solve one particular problem, means I should achieve this particular goal. To achieve this particular goal, what are the main functional components I should solve to achieve this particular goal? For example, I will tell you air pollution monitoring. In a air pollution monitoring, what we should do actually, when I monitor the different components of a air chemical components, how it is varying in a air, then I can understand what is the air pollution is going on there. So to understand that particular concept, what are the functional components here? The functional components is like this. In one particular area in a air, I want to understand how much carbon dioxide is there, how much carbon monoxide is there, and how much alcohol content is there, and how much methane content is there. Like this, different I want to analyze. So if I want to analyze this particular thing, what are the functional components needed for this? So then I should think about the sensor. So in this particular open environment, if I keep one object or if I keep one entity, that entity should sense these particular factors and it should give the result to me. What is that entity? That entity is nothing but a sensor. What is that sensor which will give me the gas levels? So then I should debug on that particular thing. That is MQ6, MQ7 is there, MQ135 is there, like that different sensors is there. So which sensor is suitable for my particular project? Like this, the main functional component, okay, it's ready with me. So how I should handle with that particular data, how I should differentiate the methane and how I should differentiate the carbon monoxide from one sensor which is giving a value. So there I need some device or some board, so which I should do, which I am able to do a coding and all. So that is a one main component. Like this, how I am relating these components. From there, again I should go for with other things. That is how these particular data should transfer to the cloud. Why? Because I should do predictions. What is that? From 3 months, this is a problem which I am facing, means this is a component which is varying largely, affecting largely in that particular area. For example, carbon monoxide or a carbon dioxide which is affecting more in that particular area. So then in coming 3 months, what will be the stage of that? What will be the stage of carbon footprints? If I want to tell all these things, I need some place to store the data. Let it be a cloud there. So how a cloud computing will work? Then from that cloud computing, how I can do the analytics. So everything is interconnected here, starting from a sensor to that particular stage. So that will be there in this reference model. So functional components of a system, as well as how the system works and how the system is deployed. This is another one very important concept. So how system is deployed in a real-time environment. This is very much important. I will do a prototype always. I will show a prototype facing like this. I will keep in water the moisture level sensor in a glass of a water and take out like that. I am showing. What is a real time? In real time, if I keep in a field soil, what will be the working nature of that particular thing? So how the system is deployed, what information the system should process, all these things will be there in a reference model. Coming to the next thing, and R means architecture reference model is useful as a tool that establishes a common language across all the possible stakeholders of an M2M or IoT system. Why? You can ask me the question, sir, why we need this architecture reference model? I will tell you, see, in a worldwide, everyone should follow some particular model. For internet means TCP, IP reference model we are following. Why we should follow? Worldwide acceptance, everyone should have a same thing. Like that, for an IoT project, ARM is a one which is given by an IoTA. So that if everyone will follow that particular architecture, a common language or a common type of project in the way of connectivity will be there across the stakeholders of a world. So where M2M systems or IoT systems will be there. So it can also serve as a starting point for creating a concrete architectures of a real systems when the relevant boundary conditions have been applied. So why we need, so actually to say it will serve the starting point to create a concrete architectures for especially for a real systems where we should do with an IoT project and all, always we'll deal with a real systems or real environment. So when the relevant boundary conditions will be there, means I want to put in a boundary for my IoT projects and all. For that, so I need some architecture. So for example, the stakeholder requirements, design constraints, and the design principles. So this should be a relevant and it should be like one type of a standardization where everyone will follow, especially the stakeholder requirements, how to solve the stakeholder requirements, how the functional requirements will be evaluated from that, and after evaluating a functional requirements, how I design constraints. Okay, these are all the functional requirements. I want to go for designing this functional requirements or solve this functional requirements. So what are the design constraints for that? If I want to solve this functional requirement, what are the components needed? How to design? How to solve that? For that, what are the constraints I am having? And what principles I should follow while designing one type of things? So these things will play a very much important role in a IoT project. Next, several reference architectures and models exist both for the M2M and IoT systems. The M2M system architectures are naturally more communication oriented, while the IoT related reference architectures and models are more holistic in their scope. So now discussing on this, several reference architectures and models exist both for M2M and IoT system. There are many architectures which you can follow, especially for a M2M, means machine to machine system architecture. The communication plays a very much important role. But in IoT reference architectures, the models are more holistic in their scope. What is this holistic in their scope? Means here not only we are concerned with a network, how we are going to connect, finally how the knowledge frames is coming out from that IoT and how we are giving to the different stakeholders in their understanding level, how we are representing the output. So that plays a very much important role in IoT. Now coming to the European Telecommunication Standard Institute, that is ETSI. So this is ETSI is a one standards institute which is there for M2M and one M2M projects which is there. And we'll discuss full depth on this particular, especially ETSI. M, usually we can say M means it's meant for missions. That is European Telecommunication Standards Institute for the missions. So in this, we'll see how this particular architecture will work, and what are the standards which will help, and what are the standards will be there in that. The first point in this is the European Telecommunications Standard Institute, that is ETSI, in 2009 formed a technical committee on M2M topics aimed at producing a set of standards for communication among machines from an end-to-end viewpoint. So in 2009, this Standard Institute formed a technical committee especially for M2M machines. That is how a machine will communicate with another machine which is far away. Either the machine means here, don't think like that. Here a machine means a smartphone will be there, and as well as one machine will be there, or one sensor device machine will be there. How the smartphone will communicate with this machine. Even smartphone is a machine. So this is a machine to machine. How a machine to machine communication you are doing based on a boundary or a area. You may use many networks. It's not on a case. So that is a one important thing. Coming to the next thing. Uh, the next thing is your the ETSI M2M specifications are based on specifications from ETSI as well as other standardization bodies such as IETF, Internet Engineering Task Force. Now, so ETSI M2M specifications are based on specifications from ETSI. They have taken their own. They have borrowed from other bodies also. What are the other bodies? The other bodies are IETF, which is a one Internet Engineering Task Force. Means your TCP/IP, your internet things, everything will be given from them. So 3GPP, that is a third generation partnership project. OMA, Open Mobile Alliance, everything is needed here. How a mobile architecture, how mobile should works and all. That's why OMA. And broadband forum, that is BBF. So how a broadband connectivity should be given, how internet protocol should be used, combining all these things with a mission. So that's why ETSI has borrowed all these things, and they made one standard specifications for an M2M. Now, European telecommunication, that ETSI M2M high level architecture. You can see here the architecture which we had discussed in a last unit also. Now again in detail we can discuss here, and you can see here how a network domain and device and gateway domain, how these domains differentiated here. And you can see in a device and gateway domain what we are concentrating. We are concentrating on M2M area network. That is within a boundary how a device to device a connection can be done. M2M service capabilities, M2M applications, gateway, M2M devices, and M2M service capabilities. Again, it will be taken to the network domain if you want a large area to be connected. There, how you are using the access network, core network there. Again, same M2M management functions. Sorry, and service capabilities and applications. How you can elaborate your M2M domain, especially using in a network. So this is a high level architecture which is there, which we had discussed already. And with this architecture keeping as a base architecture, the ETSI has designed, and we'll move further. The high level architecture is a combination of both a functional and topological view, showing some functional groups clearly associated with the pieces of physical infrastructure, while other functional groups lack specific topological place. Now you take the first thing here. What is the first thing here? In a high level architecture, we are seeing both the things. That is two things we are observing here: the functional and the topological. In two things we are viewing, or two components we are viewing. What are the functional components here, and what are the functional requirements? What is a topological view? Where I should place this? If I place this component here, whether this functional requirement will be solved. Okay, after placing this, I can make a functional group. How this functional group will be interacted with other functional group, like that. So clearly associated with the devices and gateways. So that we have discussed, the placement is very much important here. Where I should place the device, where I should place the gateway, how, which type of network it should be connected, and how a broadband network, when the broadband network it should be connected. So that things plays a very much important role here. There are two main domains which will be there here. That is a network domain and a device and gateway domain, which we have observed in a figure. The boundary between these conceptual separated domains is the topological border. Observe the word, underline the word topological border. This is very much important. So here also in my, I can say device and a gateway domain, I am using a network. Then you can ask me the question, sir, you are using a network here also, then how a network domain will be separate? No, here connecting a device to device within a boundary, I'm using a device and gateway network. That is different. Are you getting my point? So that is the one important thing. That's why here they are telling identifying a boundary, that means a topological placement, a boundary between the physical devices and gateways and the communication infrastructure. So, okay, my device is assume that I want to place my project in some 1 kilometer. In a 1 kilometer, if I want to place my project there, device connecting network is very much important for me. So that network is different. So after that, taking entire project into consideration, how I'm connecting to the cloud is a network domain. So that is the topological border between the physical devices and the gateways and the physical communication infrastructure, that is access networks. The device and gateway domain contains the following functional or topological entities. So first we will see in a device and gateway domain what are the things it will be there. So M2M device, that's the first devices will be there. This is a device of interest for an M2M scenario. For example, a device within a temperature sensor or an M2M device contains M2M applications and M2M service capabilities, and an M2M device connects to a network domain either directly or through an M2M. So this is what M2M device will have. Very simple. It will be connected with an sensors, and these sensors will it will take a data and it will evaluate that particular data according to my requirements, my project requirements. I will find a threshold, whatever is there, and I will do. That are the service capabilities, and that are the final application. This is a value which I need. That is M2M applications. These things it has to extract some value. What's a gateway? Direct connection will be there. The device can be directly connected to the internet. Yes, the M2M device is capable of performing registration, authentication, authorization, management, and provisioning to the network domain. Yes, that is in Raspberry Pi or Arduino or whatever may be the Node MCU, whatever we are using, that are all the direct connections which we are using. That is, there I can use a Wi-Fi model with this sensor connectivity also. I will take all data. After connecting, means I have to enter a SSID, password, and the API key for authorization and management, network provisioning, connectivity, everything I should see. That code is different, right? We have seen that in our projects. So the direct connection also means that the M2M device contains the appropriate physical layer to be able to communicate with the access network. That is, up to data link layer here, it's already there in my device only. So which I can, means my Wi-Fi model only. I can connect directly to the internet or an access network. So that may be one type. Rather than what is the other type? Through one or a more M2M gateway. I will use a gateway. This is a case when the M2M device does not have the appropriate physical layer and an data link layer. Means that layer is not there. Assume it's not at all a network supported thing. For example, Arduino, network, it never supports a network. You can do whatever code, everything you can do. You can use a Bluetooth. So no internet. When I will tell internet concept, then only a Wi-Fi model will come into picture. Or Node MCU, you are going to fix for that. ESP8266, you are going to adapt for that. Otherwise, you don't adapt. Then ESP8266 is a gateway. Are you getting my point? That is a gateway. Arduino is not a gateway. Arduino is just a device. Now, Arduino is a device which will perform all your activities with a sensor, everything afterwards. If you want to transfer a data where with a TX and RX, the node ESP8266 model means Wi-Fi model has been connected, so then you can send. But in case of Raspberry Pi, it's not a case. When you use Node MCU directly, it's not a case. So, but in especially Arduino, this will be the case. So where a network layers will not be there. So additional things you have to take into the consideration. So the access network technology, and therefore it needs a network domain or a proxy. 100%. All my students in your projects, you have faced this problem also, and you have told that, sir, how we should connect to the network, and you have made some R&D works also, how to connect TX to RX, RX to TX of the Wi-Fi model with the Arduino. That things and all you have did already. Coming to the next, the device and gateway domain contains the following functional topological things, that is especially M2M area network. What is this area network? This is typically a local area network LAN or a personal area network PAN, and provides a connectivity between devices and connectivity between gateways. Typical networking technologies are IEEE 802, you can use Bluetooth, you can use for a connections, and you can use wireless connectivity also, and you can use a Zigbee also. It's left to you people. Then what is M2M gateway? If you want to connect to the internet, the device that provides a connectivity for M2M devices in an M2M area network towards the network domain. I want to connect to cloud. So for that, what you are using, that is a gateway. Means Node MCU is a gateway for your Arduino, or ESP8266 is a connectivity there. The M2M gateway contains M2M applications and M2M service capabilities. The M2M gateway may also provide the services to other legacy devices that are not visible to the network domain. So that things will be done always with an M2M gateway. Coming to the next, the network domain contains the following functional and topological entities. Now we'll see what is the access network, which is there in a network domain. This is a network that allows the devices in the device and a gateway domain to communicate with the core network, that is your internet. How I can communicate with the internet? That's a core network which I am having. Example, access network technologies are you can use your DSL connections, means Ethernet connections you can use, or wireless connections you can use. What are the wireless connections you can use? WiMAX you can use, or wireless LAN connections you can use. Even satellite, direct satellite connections you can use, or EU-TRAN connections you can use, GRAN connections you can use. So these are all the connections which will connect to a four-place devices. So that's the access network. Okay. So from this, what's a core network? Examples of core networks are your 3GPP core network. Your internet means mobile third generation protocols, which is going to connect for that. So ETSI span networks will be there. So IP connectivity, through IP address I'm going to connect to the internet. Usually all our projects we are connecting with an IP connectivity only. Sorry, service and network controls, how we are going to do. Interconnection with other networks and roaming, how we are going to take into the consideration. And these are all the things which will be there in a core network. That is how far we are going to connect. In a last example, when in a project demo, Prashant Reddy is there in Andhra, and Murugesh is there in Malur. With his mobile, he is operated the pump, means manually, means switching on and off he has did, and we have seen lively how it is in a Malur, the pump which is there, which is off and on. So for this, I will ask you, tell me the network thing. So how it has been connected. Maybe like that, he is connected to the hotspot. Maybe that's the access network, right? So from that means hotspot, whatever is there, that is a wireless LAN, whatever is there. So from there, it will connect to the mobile network, and core network it will connect. That's a mobile 3GPP network it will connect. So it will connect to the public internet through IP connectivity. Once it is connected to the internet through the IP connectivity, wherever from Andhra, whatever there, from foreign also, you can operate the motor. So that is the thing here. That is M2M service capabilities. These are the functions. What are the service capabilities? These are the functions exposed to the different M2M applications through a set of open interfaces. These functions use underlying core network functions, and their objective is to abstract the network functions for the sake of simpler applications. So what is this service capabilities? What my M2M project has to do? And always, whatever a service capabilities is there, the service capabilities should point out to my application, final application. Underlying the core network functions, whatever is there, or the objective main, it should reach my objective. What the objective is to abstract the network functions for the sake of the simpler application. I will group all the network functions together. Ultimately, the data should go and sit in a cloud. This is my aim. So whatever the networks means, access network you are using, internet you are using, whatever you may use, I never think on that, but finally my data should be there on the cloud. So that is a service capability. So that thing should be there here. Coming to the next thing, that is M2M applications. These are the specific M2M applications that utilize the M2M service capabilities, means whatever application is there, final application. I should go and sit in a cloud computing. That's my application. So what is this? To go and sit in a cloud computing, service capabilities should be taken here through the group interfaces. Now, network management functions. These are all the necessary functions to manage the access and a core network. So that is called as a network management functions. And M2M management functions. These are the necessary functions required to manage the M2M service capabilities on the network domain, while the management of an M2M device or a gateway is performed by a specific M2M service capabilities. What are the service capabilities or functions? You can see here, M2M service bootstrap function. That is how the device will start, how it will work. So that's a main thing. Then afterwards, the authentication server. That is how the M2M authentication will be done. The device authentication will be done. This is very much important. Using which username? For example, I'm going to connect to a ThinkSpeak. I'm going to connect to a ThinkSpeak. My device is going to connect to a ThinkSpeak. How I am doing a authentication here? User and username and a password for internet. That we will check. Once it's connected, especially how a ThinkSpeak will check. ThinkSpeak will check through either write API is there, token is there, or read API token is there. That token is the one which is known to only the customer there. No other will know that. Means who is doing a code, he only knows that. So that is the authentication server which will be there in a ThinkSpeak, which will evaluate based on API keys. So that is a important thing which we should take into the considerations. Now coming in depth with a high level architecture, how these things will be there. So we'll take a break here and we will move with the next class. I'm having some meeting related with other things. So I will stop here my lesson today and we'll go with the next things. Just a minute. Yeah. Any doubts is there? Only 33 members are there today. Why? What's the problem? What's the problem? Huh?
No, sir.
Company is there? Any company is there?
No, sir.
Then what is the problem? Hmm?
No idea, sir.
So okay, everyone, you send a message in a chat box. I'll consider that as attendance. I think everyone has sent. Huh? Okay, send it quick. Send a message. So I will consider that as attendance. And your marks has been already uploaded in a BIMS, except 5 members. Maybe you will get tomorrow, I think. It will be sent as an SMS. So you can see your marks there. Almost all okay. Everyone has did, but somebody still you have to improve a lot. Many means some 3 4 members who are there in the way of writing. Still you have to improve a lot. Okay, I think everyone has sent a message. I'll stop the recording.